Hello everyone, this is question number 4 from homework number 12. It's very similar to question number 3. They follow the same steps. The question says, use the derivative of a function shown below to determine the open intervals on which the function is increasing or decreasing and any relative extrema, and the x values at which the extrema occur. The function f of x is equal to 4x cubed plus 54x squared plus 96x minus 9. The first thing that we will need to find is to find the critical values. We can do that by making the derivative of the function, or the derivative function is equal to 0 and solving for x. So the first step would be finding the derivative of f of x. So I will do that. F prime of x is equal to 12x squared plus 108x plus 96 minus 0. Then I will make this equal to 0 in order to solve for x, which will give me the critical values. First, I will need to divide everything by 12. It'll be easier for me to work with it this way. So I will get x squared plus 108 divided by 12, 9x, plus 8 equals 0. Then I will solve this quadratic function. I will have x, and x, I'm looking for two numbers. Their product is 8 and their sum is 9, and that those values are 8 and 1. 1 times 8 is 8, 1 plus 8 is 9. I'm going to solve each factor. X plus 8 equals 0. That will lead to x is equal to -8, and this is the first critical value. The second critical value, x plus 1 equals 0, that will give me x is equal to -1. So the critical values are -8 and -1. I'm going to put them into my question, and I'm going to separate them with commas. -8, comma, -1. The second part of the question is asking about the open intervals on which the function is increasing and decreasing. In order to determine that, I'm going to plug the critical values on a number line to determine how many intervals I will need to test. So here is an open number line, and I will have -8 here, and I will have -1 here. Of course, I divided my number line into 3 parts. Those are the intervals that I need to test. The first interval comes from -infinity to -8. The second interval goes from -8 to -1, and the third interval goes from -1 to +infinity. Then I will have to choose testing point from each of these intervals and determine the sign of the derivative, and that will determine whether the function is increasing or decreasing. If the derivative is positive on that interval, that means the function is increasing. If the derivative is negative on that interval, that means the function is decreasing on that interval. I will build a table right here to determine that. I call it the sign diagram, and then we will determine on which intervals the function is increasing, on which intervals the function is decreasing. So I created the table here. The first row has the intervals that I wanted to test. The second row has the testing points that I'm going to choose, and then I will plug these testing points into the derivative in order to find the sign of the derivative on each interval. So the first interval goes from -infinity to -8. A suitable number will be -9. I'm going to use the test. The second interval goes from -8 to -1. I'm going to choose -2. And then from -1 to +infinity, I will use 0. Then to determine the sign of the derivative, I'm going to use Desmos because it's more convenient for me. So what I did here on Desmos is I typed the derivative function. I called it h of x. I'm going to find the value of h of x at each of these testing points. So h of -9 to find the value of the derivative at -9, which is the first testing point. The answer is 96, which means the derivative is positive on that interval. So I'm going to say positive here. I only care about the sign. Of course, I don't care about the value. And then I'm going to plug -2 into the derivative one more time. So -2 instead of -9. and the value here of the derivative is negative. So I'm going to go to the table and I'm going to record that, negative. If I plug 0 into the derivative, that's easy to determine. These will cancel and I will have 96, which is positive. I'm going to conclude that I have two intervals in which the function is increasing. Those intervals are the first interval from negative infinity to negative 9 and from negative 1 to positive infinity. So to write it down here, it says that I have to separate my intervals with commas, negative infinity to negative 8, comma from negative 1 to positive infinity. And the function is decreasing on one interval, which is from negative 8 to negative 1. Negative 8 to negative 1. And then the third part and the last part is to record the relative maximum and minimum of the function and the x values in which they occur. So the x values where the relative maximum occurs is basically where the function goes from increasing to decreasing, increasing to decreasing, and that value happens at negative 8 in this case. Let me draw the picture for you. So the function is basically increasing here, and then it goes decreasing here, and then it goes increasing here. Notice how this point is a maximum and happens when x is equal to negative 8. So the value at which the relative maximum happens is negative 8. Let me find the minimum and then we will find the relative maximum and the relative minimum. So the minimum happens when the function goes from decreasing to increasing, which is this point. And as you notice, it happens when x is equal to negative 1. So I'm going to say negative 1 here. Now I will need to find what is the relative maximum and what is the relative minimum. We know where it happens, but we don't know what it is. So to do that, we will take the x value and plug it into the original function to figure that out. So I will do that. So to do that, I went ahead and typed the original function into Desmos, and now I will use Desmos to find the value of the function at a certain point. So I know that the x value where the relative maximum happens is negative 8. That means the relative maximum is basically f of negative 8. So I'm going to say this is f of negative 8, and it computes it for me at the value of 631. So I'm going to say here 631. And then I will find the relative minimum the same way. So I know the x value where the relative minimum occurs, and that is negative 1. So I will put f of negative 1 to determine the minimum, which is in this case negative 55. And that concludes this question. I hope this video helped you understand how to figure out this question, and I will see you in a different video.